Hi everyone. Welcome back to our video lecture on numerical methods. In the previous lectures, we have discussed about interpolation, the theory behind interpolation and the terms corresponding to interpolation, namely interpolating function, forward difference, backward difference, shifting, central difference. All these terms and some illustrations we have discussed. Also, we have derived some relations between this forward difference, backward difference, shifting, and all these things. In the last video, we have discussed and derived Newton's forward formula for interpolation and backward formula for interpolation. And in today's lecture, we are going to discuss about some problems for interpolation. We will be illustrating 2 or 3 problems in today's lecture. Let us quickly recall what is Newton's forward interpolation formula. Yn of x is equal to y naught plus p delta y naught plus p times p minus 1 divided by 2 factorial delta square y naught up to p minus 1, p minus 2, p minus n plus 1 divided by n factorial delta to the power n y naught. This is the nth degree interpolation formula. And here p is x minus x naught divided by h. Now we are going to use this formula for some particular problems. Let us see the problem. Let us see our first illustration. We have to find a cubic polynomial that taking the values 24 at 1, 120 at 3, 336 at 5 and 720 at 7. After constructing the cubic polynomial, we are supposed to calculate the value of the function at 8. For this one, what we will do is we will construct the forward difference table first as follows. We can see the table. The first column represents x value, second column represents y value. The third column is first forward difference, that is 120 minus 24, 336 minus 120, 720 minus 336. So we will get 96, 216 and 384. Next column is second order forward difference, which is 120 and 168. And last one is delta 3, which is 48. If you further calculate, it will be 0. Delta 4 is 0. Now, here we can observe that h is equal to 2 and x naught is equal to 1. So we will define random value x as x is equal to x naught plus ph, that is x equal to 1 plus 2p. From that one you can calculate p as x minus 1 divided by 2. Now let us apply this in the Newton's forward interpolation formula. For y naught we will get 24, delta y naught 96, delta square y naught 120, delta cube y naught 48 and the remaining terms are 0. And p is x minus 1. So p times p minus 1 is x minus 1 by 2 times x minus 1 by 2 minus 1. p minus 1, p minus 2 become x minus 1 by 2, x minus 1 divided by 2 minus 1, x minus 1 divided by 2 minus 2. Now this problem reduced to a simple algebra and we can simplify it as y of x is equal to x cube plus 6x square plus 11x plus 6. So we can verify that this formula satisfies all the given conditions and we want to find y equal to 8. There are two ways to find y equal to 8. The first one is in p we can use x as 8. So p will become 8 minus 1 by 2, 7 by 2. We can substitute in the Newton's forward difference formula, or directly we can substitute x equal to 8 in this formula. In both the cases, you will get y of 8 is 990. Now we will go to the second problem. Using Newton's forward difference formula, we will find the cube of first n natural numbers. So here Sn is equal to 1 cube plus 2 cube up to n cube. So Sn plus 1 will be 1 cube plus 2 cube plus n plus 1 whole cube. So if you take delta Sn, it will be n plus 1 whole cube. Now delta Sn is n plus 1 whole cube, then we can calculate delta square Sn. Delta square Sn will be delta Sn plus 1 minus delta Sn, which is n plus 2 whole cube minus n plus 1 whole cube, which is 3n square plus 9n plus 7. Delta cube Sn will be delta square Sn plus 1 minus delta square Sn, which you can calculate as 6n plus 12. Delta to the power 4 Sn is 6. So if you calculate the further terms, delta raised to 5, delta raised to 6, all these things will become 0. So we can assume that since only 4 powers are there of delta, it is a 4th degree polynomial. Now we will calculate values of S1, delta square S1, delta cube S1, delta 4 S1. So S1 is 1, delta S1 is 8. This we can find easily from the previous one, where substitute 1 in place of n. Delta S1, delta square S1, delta cube S1, delta to the power 4 S1. So we will get the values as 1, 8, 19, 18 and 6. So this corresponding to y0, delta square y0, delta cube y0, delta to the power 4 y0 in our Newton's forward interpolation formula. Also, now we want to calculate p. Here x is n and x0 is 1. Also h is also 1 because we are calculating the values 1, 2, 3, etc. S1, S2, S3, etc. So from that one we can calculate our p value as n minus 1. Now once we got p value as n minus 1, substituting in this equation, we will get Sn is equal to 1 plus n minus 1, 8, n minus 1, n minus 2 divided by 2 times 19, n minus 1, n minus 2, n minus 3 by 6 times 18, plus n minus 1, n minus 2, n minus 3, n minus 4 divided by 24 times 6. After simplification of these things, using some basic algebraic techniques, you will get the value of Sn as n times n plus 1 by 2 whole square. Now we will move to the third illustration, which we have introduced in the previous video. You are supposed to find the missing term of the following table. You might have identified the pattern and find the value yourself. Now we will use Newton interpolation formula. Before going to Newton interpolation formula, you want to note one point here. You have a function and 4 values of the functions are given. We are not aware of the other values, so the pattern may not be correct. The pattern you identified may not be correct. So let us see the problem now. We will construct the forward interpolation table. So first column is x value, second column is y value. Since value at 3 is not given, we are constructing for 0, 1, 2, 4 and 1, 3, 9, 81, delta, then delta square, delta cube. All these values we have calculated. The table is there. And if you continue, delta 4 y0 is equal to 0. So delta 4 y0 equal to 0, and the relation between delta and the shifting operator E, we already know it is E minus 1. Delta is equal to E minus 1. Now I am going to apply this in our problem. Delta to the power 4 y naught is equal to 0. That is e minus 1 to the power 4 of y naught is equal to 0. E minus 1 to the power 4 you can expand. You will get as e power 4 y naught minus 4 e cube y naught plus 6 e square y naught minus 4 e y naught plus y naught equal to 0. Shifting operator gives e to the power 4 y naught is y4. E cube y naught is y3, e square y naught is y2, e y naught is y1. Then in this y4, y3, y2, y1, y0, except y3, all the values we have. So let us substitute these values here. So now it becomes an equation with single unknown y3. You can simplify and you can calculate y3 as 31. You can try this exercise yourself.